Good morning everyone. So today I'm gonna solve this question paper Neet 2025 physics because this is the toughest paper, and also most of the solutions that I found in internet were not complete. What they have done is they have provided incomplete solutions, or some of them just given the answers without any explanation. So I am here to provide the complete solutions in my using my methods. And by the way, now the time is 4:15, so let's not take much time and let's start. And also I forgot to mention that I'm using this serial number question paper with the serial number 46. So if anyone wants to find the PDF of this paper, you can find it in the description of the video. So please do check it out. Now let's start with the first question. The very first question says that there is a physical quantity. I'm not going to read the whole question. You just go to the question paper that I'm going to give in the description. So first question is as follows. There is a physical quantity P which is given by a power 3 b power 2 upon c square root of t. Now I need to find the percentage error in P. How do I do that? Delta P by P should be equal to 3 times delta A upon A plus 2 times delta B upon B plus delta C upon C plus half delta D upon D. Now let's plug in the values. Delta A by A, delta B by B, delta C by C, and delta D by D is given. Now I'll just plug in the values. So this is 3 times delta A by A is 1 plus 2 times, and delta B by B is 3 plus delta C by C is 2 plus half of delta D by D is 4. Now this turns out to be 3 plus 6 plus 2 plus 2, which is 6 plus 2 8 plus 2 10 plus 3 13. 13% is your answer. So this is your final answer. So let's put it in a rectangle since this is our final answer. So this is all about the first question, and now let's check out the second question. Now the second question is as follows. We are given with 3 polarites. Here is the second question. We are given with 3 polarites. It said this is polarite 1, and this is the final polarite 3. And it is said that these 3 polarites, these 2 polarites are perpendicular to each other. So the angle between these 2 polarites, let's say this is 1 and this is 2. The angle between them is 90 degrees. Now what we need to do is we need to find the intensity of light which is coming out of this third polarite. And I forgot to mention there is another polarite. Let's draw it here, which is making an angle of theta with the first polarite. And what they are given is the intensity with which the light is coming out from the polarite 1 is given as I. So this is all the information that they have given. So what we need to find the intensity of the light which is coming out from polarite P3. Let's call it as I prime. So I need to find this value I prime. So first let's find this value. Let's say this is I1. Let's call it as I2, right? So I can write I1. I1 is equal to I into cos square theta, because this is what we call it as Moore's law in polarization. So I is equals to I1. I can write I1 is equals to I into cos square theta. Now if this is theta, now I can clearly say that this should be 90 minus theta, because total angle, this is theta, and total angle is 90 degrees. If this is theta, the other should be 90 minus theta. I can write I2. I2 is equal to I1 into cos square 90 minus theta, because this angle is theta and this is 90 minus theta. So this polarity is making an angle of 90 minus theta with the P3. So I should write cos square 90 minus theta. So I will just substitute this I1 here. So which turns out to be I cos square theta into cos square 90 minus theta. Now let's use some trigonometry, which is cos square 90 minus theta is sin square theta. I cos square theta into sin square theta. So what I will do is I will multiply and divide by 4, so that I can write this whole term 4 sin square theta into cos square theta, as you can write this whole term as sin square 2 theta. So this is another mathematical equation you better remember, which is as follows: sin 2 theta is equals to 2 sin theta cos theta. Now what is this value? This is I by 4 into sin square. Theta is given to be, for us theta is given as 22.5 degrees. So 2 theta turns out to be 45 degrees. Sin square 45, which is I by 4 into 1 by 2, which is I by 8. This is your final answer, which is option B, I guess. This is option B. Now this is all about question number 2. Now let's jump to question number 3. So guys, now we are at question number 3. Question number 3 as follows. Now we got 2 different copper coils in which the same current is flowing, which is 2 amperes, and we need to find the ratio of their magnetic moments. So before this, you need to understand what is a magnetic moment. Let's write it as 3 here. Magnetic moment is nothing but I times A, current into area. This A is area. So current is same, so I can write M1 by M2 should be equal to A1 by A2. But what is A? A is nothing but area, which is pi r square. So I can write A1 by A2 is R1 by R2 whole square, which is 1 by 2 whole square, which is 1 by 4. So M1 is to M2, or again the ratio of the magnetic moments is 1 is to 4, which is option 4. So this is all about third one. Up until now we are all good. We didn't come across any tough questions. Now let's move on to the fourth one. Fourth one, here is fourth one. Now fourth one is as follows. We got a vernier scale, we got a vernier calipers, and now we need to find the measurement. First of all, what they are saying is, they are saying that 10 vernier scale division is equal to 9 main scale division. This is equal to 9 main scale division. So I can write one vernier scale division is equal to 9 by 10 main scale division, which should be equal to what? 1 MSD is given as 0.1 centimeter. So I can write it as 9 by 10 into 0.1. Now let's find the least count. Least count of vernier scale is given by least count is equals to 1 main scale division minus 1 vernier scale division. So which is 1 main scale division is 0.1 minus 9 by 10 times 0.1. Let's take this 0.1 common, and we'll get 0.1 times 1 minus 9 by 10 is 1 by 10. So this should be 0.01 centimeters. So this is our least count is 0.01 centimeters. But this is not what we want. We are not close to the answer yet, but we are on the way. Now what we need, and also they have given that the zero vernier scale is at x is equals to 0.1. X is equals to 0.1 centimeters, where the jaws of vernier caliper are closed. So this is what we call it as zero error. This is zero positive error. Zero positive error. Now, whenever you get zero positive error, we subtract that, and if you get zero negative error, we add. Let's find the reading. Final reading is given by main scale reading plus least count times vernier scale reading plus positive zero error, which I'll call it as E. Now this is zero positive error, so I need to subtract, right? So you just write it as minus E because zero positive error is subtracted. But anyhow, any error is generally subtracted. If it is negative zero error, minus of minus becomes plus. So let's not worry about it. So this is main scale reading is how much? They are given it as 5 centimeters. 5 plus least count is 0.01. Since everything is in centimeters, we need not worry about the units forever. And 1 year scale reading is given as 8 minus 0.1. So this is 5.08 minus 0.1, which turns out to be 4.9. So this is your final answer. So this is how we solve this question. So in this we need to find the least count, and then again you need to use the zero error. So this is a little time taking question. So here comes the time taking question. The first time taking question. There are a lot of time taking questions which we are going to explore quite soon. Now what we'll do is we'll move on to question number 5. So in question number 5, what they're saying is we got a photon and also we got an electron, and we need to find the ratio of the wavelength of photon and the de Broglie wavelength of electron. So let's find it out. What is the wavelength of photon? We need to find wavelength of photon by writing here as wavelength of photon upon wavelength of electron. By the way, if you look carefully, they are saying that they both have the same energy. The kinetic energy of photon is, or the energy of photon is equal to the kinetic energy of the electron. Now I can write, let's find the wavelength of photon. Lambda, for wavelength of photon, lambda is given by h by what is lambda? E, you can write this. Energy of photon, E is equal to hc by lambda of photon. So I can write wavelength of photon. We write this spelling. Wavelength of photon should be equal to hc upon E. So this is our first equation. Now let's find the wavelength of electron, because electron is also quite important. We need a wavelength of electron, de Broglie wavelength. We call it as de Broglie wavelength because this is the wavelength associated with the particle nature. So energy of photon is given. The energy is equals to p square by 2m. So I can write momentum is equals to root 2m into E. But what is wavelength? We have this de Broglie's equation which says that lambda is equals to h by p. So h by root 2m into E. This is wavelength of electron. I will write it as lambda E. Now this is your second equation. Now what I need to do is I need to find the ratio of this and this, which turns out to be hc by E upon h by root 2me. Now h gets cancelled, and this is c square root of 2me upon E. Now this can be written as c times. Let's bring this E inside the root so that you will get square root of 2m upon E. This is your final answer. So the correct answer to this question is option C. So this is your correct answer. Now question number 6.